Hello everybody and welcome to Lecture 10. This is Chapter 9.1 through 9.3, so sections 1 through 3 of Chapter 9. Okay, let's get started. So this chapter is all about life in the universe, which is one of the big questions, as you might imagine, in astronomy, because we not only study stars and planets and other planets around other stars, etc., but we would really like to know if we're alone in the universe. And so that's a big field of study. And what do we want to know? Well, we want to use different things like understanding when life arose on Earth, how it arose, what are the necessities of life, and all of these questions, including are we alone, are something grouped into a field called astrobiology. And it's a relatively new science whose goal is to place the existence of life into this sort of planetary and cosmic context. And what I mean by that is not just understanding life itself and understanding how it arose on Earth, but using that knowledge, anything we glean from that, to understand how or when or if life could exist outside of Earth. So let's look at a short intro video about that.
Are we alone in the universe? Whether the thought of alien life sends shivers down your spine or makes you jump for joy, you have probably asked yourself this question at some point. Astrobiologists study life in the universe, looking for the answer both in outer space and right here on Earth. To recognize signs of life elsewhere, we need to learn more about it, and there is no better or more accessible lab to do that than our own planet.
Great timing.
Sorry, video paused.
Plants are pretty fragile beings that require very specific conditions to survive. But some life on Earth is not as hard to please as we are. Astrobiologists are looking at simpler forms of life, microorganisms called extremophiles that can thrive in extremely harsh conditions, a bit like those found in planets and moons elsewhere in our solar system. One of the most inhospitable environments where we have found life is the Dallol crater, located in the Danakil Depression in Ethiopia, the hottest place on Earth. You wouldn't expect to find creatures prospering in its bubbling lakes of boiling water, acid pools, or sulfur spouts, but extremophiles can inhabit these environments. Scientists are using this alien-like world as a field site to find out how life might arise on other planets, such as Mars. Earlier in its history, the red planet was a lot warmer and wetter, resembling the Earth when life first emerged here. Mars missions have shown that liquid water used to be abundant on the planet's surface and have discovered organic molecules, the building blocks of life. Life could indeed have flourished on the red planet at some point in its history. The minerals and water chemistry in Rio Tinto in southern Spain resemble the wet environments on early Mars. This is another site scientists are using to understand what kind of life could have emerged on the red planet and how biosignatures could still be preserved there. The briny Tires Lake in central Spain has features like those found in one of Jupiter's moons, Europa. This is one of the most likely locations to find life in the solar system because it is believed to have a sea of salty liquid water underneath its icy crust. By studying the extremophiles that inhabit the Tires Lake, astrobiologists can find out what kind of creatures could possibly lurk in Europa's ocean. There could also be life in the solar system in an environment very different to anything we can find on Earth. Titan, the largest moon of Saturn, is much like our planet. It has a dense, nitrogen-rich atmosphere and liquids flow freely on its surface. However, Titan's lakes, rivers and seas are made of liquid hydrocarbons, methane and ethane. Any life existing on the surface of this moon would need to use these solvents in place of water, an exotic chemistry compared to organisms found on our planet. Life as we know it could well be found outside our solar system. Over the past 2 decades, astronomers have discovered thousands of planets orbiting stars other than the Sun. Many of these extraterrestrial planets are in their star's habitable zone, a range of orbits also called Goldilocks zone after the children's fairy tale. The little girl with golden locks hit the sweet spot when she found Baby Bear's porridge, which was neither too hot nor too cold for her. Goldilocks planets are neither too hot nor too cold to have liquid water at the surface. The conditions are just right to harbor life. Astronomers think some of these planets could be very similar to Earth and may meet the requirements for life to thrive. But habitable is not the same as inhabited. Future telescopes and space missions could allow us to analyse these planets' atmospheres in enough detail to find the chemical signatures that suggest that living beings might be present. Are we alone in the universe? We might be just a few decades, or even just a few years away from finding out.
Okay, so that's sort of a big overview of what astrobiology is. As you can see, it's the study of life on Earth, how life survives here, how it started, all the way out to trying to find life on other planets in our solar system, and maybe even soon other planets around other stars. Okay, so let's take a look at just what life is. Well, that's actually a tough question, and we don't really think of it as a bunch of features you have to be alive, but more like a process. So the basic features of living things in general are that they're made of organic molecules. They have a metabolism in which they can take in something through ingestion, they digest it, they use chemicals, whatever they're ingesting, for their life processes and some kind of excretion, so that's a metabolism. They can reproduce, right? That's the big part of being alive. Mutation is also a big part of being alive, because if you have mutation, you can make random changes that can affect your ability to adapt to an environment, etc. So you have to have the ability to have a mutation happen. And sensitivity to your environment. So let's take a look at these in more detail. So again, this idea of organic molecules, and that's life as we know it, is based on this element carbon, which is what forms organic molecules. Now, that doesn't mean that we couldn't have life formed on, let's say, silicon, right? So we don't know that that's the only way for life to form, but organic molecules are able to form these long chains and rings that are well suited for building life's chemistry. So it's kind of right now, that's really the only understanding we have of how life could be built is from these carbon-based organic molecules. Again, metabolism is the ability to consume energy and produce waste. Reproduction, the ability to create new versions of yourself, right? Mutation, that's the process in which random changes can either, affect your ability to survive, can allow you to adapt, right? And sensitivity is where you notice your environment and respond, right? Now, if you couldn't notice your environment and respond, then you may die off sooner, right? So this is something that we expect in life. Again, it's a process, not really a thing. So if you put all these sort of processes together, it's still not easy to define. And in fact, there are things that are not quite alive. There are actually some debate about whether viruses are alive. There's something called a prion, which causes mad cow disease, which is just a malformed protein, but it can reproduce and it causes disease. So is that alive? So there's a lot of sort of gray areas in this process, or in this, understanding of life. Okay. All right, let's try a question. Mutations are random changes that may or may not be helpful for survival. Well, that's true, right? You might have a mutation that causes you to be blind, and that would not be good for your survival. But another mutation might change the color of your shell, let's say, and that might allow predators not really to see you. So it really depends on the mutation, and they're random, so you're just as likely to have one that's good or bad. We'll talk about that more when we talk about evolution. So that's true. The ability to use energy and to produce waste is associated with, well, metabolism, right? Just sort of testing your remembering of the slide a couple slides back. Okay. And here's a class question, so pause the video and answer the question.